You are welcome to this next lesson about optics. Today we are discussing prescribing lenses by calculations. We have just talked about eye defects. Now let's see how we can correct the eye defects using lenses. We have a question here. Ruwen has a far point of 25 centimeters. What lens in terms of type and power would you recommend for her? This is the answer that we are striving to get, but let's see how we get to the answer. This is an illustration that we have. This is the eye, and then the question says that her far point is 25. Let's say this is the far point for the person, this lady without the glasses, 25 centimeters. And we have learned that if a person has a far point, then that person is short-sighted. For a normal eye, the far point should be infinity. Here it's not infinity, it is 25. It is worse, actually. 25 centimeters is a very small distance. So let's try to get a solution to this problem. The far point is supposed to be infinity. So what we are striving to get is, we want to get all objects which are at infinity, the object. So that's the object. We bring the image here at the far point of this lady. Meaning that if you look at the diagram, the image and the object are at on the same side, and therefore we shall put the lens somewhere here. So the lens, we don't know yet whether it's going to be a diverging or converging, but let's see by calculation. Objects at infinity, we want to focus them to the far point of this lady, which is 25 centimeters. We want to know the type of the lens and the power. We know that power of the lens is 1 over the focal length of the lens, and the focal length should be in meters. Therefore, our D image here is 25, and it's negative because the object distance, object image are all on the same side of the lens. One of them must be virtual, and the image is virtual here. So this is centimeters. Centimeters, therefore it's going to be negative 0.25 meters. And then we recall that the lens equation is 1 over f equals to 1 d object, 1 over d image. It's going to be 1 over d object, which is infinity, plus 1 over negative 0.25 meters. And therefore we get 1 over f, which is the same as power, as negative 4d. The final answer being negative means that it's a diverging lens, and I believe we have answered the question. We know that it should be a diverging lens and must have a power of 4d.